Good evening, students. How are you? This is Ankit Joshi. I welcome you all to India's largest live learning platform, GradeUp. I hope you are all staying safe, happy. I'm waiting for your responses. Good evening, Dhruv. Great. Give me 1 second. Soumyajit Datta, how are you? Good evening. Yesterday's class, have you attended? Yes. So, good evening all. Once again, a warm good evening to all of you. So today we will again continue the linear algebra part. The series is 50 most expected questions part 2. Yes sir. I can see Anu, Soumyajit, Mintu, Dhruv, Vikas Yadav. Good evening all. Let us start. So this is about me. I am Ankit Joshi. As I already told you that I have been teaching in this domain for more than 15 years and my subjects of interest are engineering mathematics, analog circuits and signals and systems. So, if at all you are planning to join GradeUp Super, if at all you are planning to take up GradeUp Super subscription, then you can use my code Joshi20 in order to avail 20% discount. So these are the batches currently going on our platform, on my organization's platform, that is GradeUp's platform. These batches are Vision, Rank Up and Gear Up. So for any other information, for further information apart from this slide, you can contact at the number given below. जसवंत भाई टेंशन नहीं लेने का. No need to take tension because nobody can take us, snatch us anything from us. Just do your work. Your work is to study and execute your plans. That's it. So these are our faculties dealing with the different batches on GradeUp platform. So just a moment. So today we will be continuing this linear algebra part, solving the questions from linear algebra, requesting all of you to hit the like button, share the link among your friends so that many of the students would be able to see this. Dear student, calculus I already completed in my previous lectures recently, just before last week I guess. Last week I have completed calculus. You can go through the lectures. I will be having some questions from calculus part as well. Shiva Sankaran, good evening beta. Good evening everybody. So there is some theory content. So I'm not going to take up the theory part today because already I have taken the theoretical part of linear algebra earlier in my previous classes on YouTube platform. Okay. Yes sir. Good evening once again to all of you. Chaliye, here comes the first question. Let's write. All the 4 entries of a 2 cross 2 matrix are non-zero. ये चारों elements non-zero हैं. All these 4 elements are non-zero. And one of the eigenvalues is 0. Okay. Which of the following statement is true? Please see here. P is a 2 cross 2 matrix. So number of eigenvalues is always equal to the order of the matrix. Number of eigenvalues is always equal to order of the matrix. Order of the matrix is 2. So number of eigenvalues will be 2. And they already said that, उन्होंने दिया है, they have given that the eigenvalue is 0. One of the eigenvalue is 0. one of the eigenvalue is 0. एक eigenvalue 0 है. So if I consider that the two eigenvalues are lambda 1 and lambda 2, so one of the eigenvalues is 0. Yes sir. And product of the eigenvalues is equal to determinant. किसी भी मैट्रिक्स की eigenvalues का product determinant के बराबर होता है. The product of the eigenvalues of a matrix is equal to determinant of the matrix. So lambda 1 is unknown, but lambda 2 is 0. So what will be the value of the determinant? Sir, determinant will be 0. So if this is the matrix, अगर ये matrix है तो determinant क्या होगा? Determinant will be P11 into P22, P11 into P22 minus P12 into P21. This will be 0. Tan tan. Just take the screenshot. We'll move to the next. आगे बढ़ेंगे हम. चलिए, let's move to the next. Come on. Very good. Shabash. The larger of the two eigenvalues of the matrix. So this is the matrix 4, 5, 2, 1. So how you find the eigenvalues? How you can find the eigenvalues? There are multiple methods. So the conventional method is write the characteristic equation. How to write the characteristic equation? You have to subtract lambda from the diagonal values. You have to subtract lambda from the diagonal values. Diagonal values में से lambda minus कीजिए और बची हुई values, remaining values should remain as it is. Yes, beta, I will try to cover complex variables and differential equations also. Don't worry. So 4 minus lambda, 1 minus lambda, 5, 2 equal to 0. Okay. So 4 minus lambda, 1 minus lambda minus 10 equal to 0. Now you can solve this. So lambda is square. Minus lambda minus 4 lambda is minus 5 lambda. 4 minus 10 is minus 6. चलिए. So lambda minus 6. Lambda plus 1. So the eigenvalues are 6 and minus 1. So the larger of the two eigenvalues. कौन सी बड़ी eigenvalue है भाई? संकेत पाटील. काहीतरी चूक झाली आहे. Ashutosh Jena, I request you to watch my other lectures on the YouTube series, beta. I already completed this part in much detail. So in this session, I am taking only problems, but earlier I have already dealt this chapter in much detail. Okay, Ashutosh, you can just watch my lectures. I request all of you to hit the like button, please. Yes, moving to the next. So this is the matrix. If the eigenvalues of the matrix are given, then x is equal to, we know that the product of, no Ashutosh, you must know the basics also. The product of the eigenvalues is equal to determinant. This is the property. Yes, sir. So what are the eigenvalues given? Sigma plus j omega, sigma minus j omega. So their product, sigma square plus omega square, and this will be equal to determinant, sigma square minus omega x. So शहीद कर दीजिए, कैंसिल कर दीजिए. x will be equal to minus omega. Option D will be the correct answer. Yes, Vivek. Very frequently I used to go to Nagpur. I request all of you to hit the like button. Yes, I'm moving to the next. So, trace of a matrix is 4. Trace means होता है sum of the eigenvalues, addition of the eigenvalues. So trace of the matrix. There is actually no success, no shortcut to success. Hard work is needed. So trace of A, lambda 1 plus lambda 2 equal to 4. Trace of A square. Trace of A means sum of the eigenvalues. Sum of the eigenvalues is 4. Okay. So trace of A square will be, what are the eigenvalues of A square? If eigenvalues of A are lambda 1 and lambda 2, What are the eigenvalues of A square? It's a property that eigenvalues of A square are lambda 1 square and lambda 2 square. So trace of A square will be lambda 1 square plus lambda 2 square. And this is given as 5. Okay. Now see here. Squaring equation 1. Squaring equation 1. चलिए equation 1 को square करते हैं. Lambda 1 square plus lambda 2 square plus 2 times lambda 1 into lambda 2. And right hand side is 16. Acha. So lambda 1 square plus lambda 2 square. This is 5. Lambda 1 into lambda 2. Product of eigenvalues is equal to determinant. Yes, sir. So 11 minus 16 minus 5 is 11. 11 by 2 is 5.5, 5.5, 5.5. This will be the answer. Take the screenshot. We'll move to the next. Okay, Vivek. Good, beta. Good. Very good. Next. Yes. Moving to the next. Chaliye bhai. You keep on ensuring that you would have hit the like button. Next. The condition for which the eigenvalues of matrix A are positive. देखो भैया, sum of eigenvalues is equal to trace. Golupal, good evening. Trace is 2 plus k. For this lambda 1 and lambda 2 to be positive, this must be greater than 0. So we can have k greater than minus 2. And product of eigenvalues is equal to determinant. This is 2k minus 1. This should be also greater than 0 if you want lambda 1, lambda 2 to be greater than 0. So 2k minus 1 greater than 0 means, क्या होगा? We will get k greater than 1 by 2. देखो भाई, this is a number line on which k values are plotted. Okay. So minus 2 is one value. 1 by 2 is another value. So you have got two regions here. First inequality shows that k greater than minus 2. It means this region. Second inequality shows that k greater than 1 by 2. So what is the common region between these two? What is the common of these two? Common of these two is this one, k greater than 1 by 2. So this will be my answer. This is a good question in fact. Yes, shabash, come on. Hit the like button. Your responsibility is hitting the like button first. While attending this session, I request all of you to hit the like button, share the link and subscribe our channel. If you are going to give me good response, I will be coming frequently on the YouTube platform to give you free classes. Moving to the next. The diagonal elements of a 3 cross 3 matrix are minus 10, 5 and 0. Acha. So sum of diagonal elements, addition of diagonal elements is the trace. So this is equal to sum of the eigenvalues. For a 3 cross 3 matrix, there will be 3 eigenvalues. Let us assume that the 3 eigenvalues are lambda 1, lambda 2 and lambda 3. So minus 10 plus 5 plus 0. So in the problem, they have given us the diagonal elements. Okay. We know that the sum of the diagonal elements is equal to trace and this trace is equal to sum of the eigenvalues. So we got the addition of eigenvalues as minus 5. Now they have given you one more point. If two of its eigenvalues are minus 15 each, they have said that. Thank you, beta Dipali. So minus 15 is minus 30. So lambda 3 will be 25. आ रहा है आपका आंसर 25. शाबाश. Yes. So we have got 63 likes. Next target is 75 likes. Huh? Yes, sir. Thanks a lot to all of you. So I got my first dislike also. Thank you. So lambda 3 equal to 25 is the answer. Moving to the next. I request all of you to hit the like button. Chaliye. So here are some notes. All the eigenvalues of a matrix represented together. Okay, shall I ask you a question? What do you mean by spectrum? What do you mean by spectrum? Spectrum of a matrix. Let me know. Okay. Answer in comments. What do you mean by spectrum? I will let you know. You comment your answers in the comment box. This is, hello, for a quadratic equation to have positive roots. For Jones Victor, for a quadratic equation to have positive roots, the sum of roots should be also positive and product of roots should be also positive. That is the rule. Okay? Yes, sir. So if M is a 2 cross 2 matrix with eigenvalues 4 and 9, मैट्रिक्स M की आइगन वैल्यूज है 4 और 9. व्हाट आर द आइगन वैल्यूज ऑफ M स्क्वायर? सर दे विल बी 4 स्क्वायर एंड 9 स्क्वायर. (16 and 81) ऑप्शन डी. शाबाश विकास. पीडीएफ मिल जाएगी बेटा, सभी को मिल जाएगी. नेक्स्ट, the number of distinct eigenvalues of the matrix. Okay, so this is an upper triangular matrix. For the number of distinct eigenvalues of the matrix, this is an upper triangular matrix. For an upper triangular matrix, the eigenvalues are exactly the diagonal elements. So here the eigenvalues are 2, 1, 3, 2, but they are asking for distinct. So 2 is repeated. So we can say that 1, 2 is repeated. So 1, 2, 3. The distinct eigenvalues are 3 eigenvalues. Number of distinct eigenvalues are 3. There are 3 distinct eigenvalues. Everybody has answered. Superb. Great, 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 great. Good. Next one. मेरे एहसास को शिद्दत न मिले, मेरे एहसास को शिद्दत न मिले, या मुझे हुक्म कनात न मिले. Just go through this point. This one is very important. If eigenvalues of a matrix A are lambda 1, lambda 2 and lambda 3, then the eigenvalues of f of A will be f of lambda 1, f of lambda 2 and f of lambda 3. Yes, please go through this point. अगर किसी मैट्रिक्स A की आइगन वैल्यूज लैम्डा 1, लैम्डा 2 एंड लैम्डा 3 हैं, if the eigenvalues of a matrix A are lambda 1, lambda 2 and lambda 3, then the eigenvalues of f of A, that is a function of A, will be f of lambda 1, f of lambda 2 and f of lambda 3. Okay, so see here, suppose you have a matrix 1 2 3 2, 1 2 3 2, and they are asking for the eigenvalues of A square plus 4A plus 3I. So what you can do? What you can do? See here, f of A, जिसकी आइगन वैल्यूज आपको निकालना है, f of A is A square plus 4A plus 3I. put a equal to lambda, put a equal to lambda. So you will be getting f of lambda equal to lambda square plus 4 lambda plus 3. Now, according to the property above, according to this property, eigenvalues of this matrix will be f of lambda 1 and f of lambda 2. And yes, eigenvalues of this matrix, if you solve, you will get eigenvalues of matrix A is -1 and -4. Therefore, eigenvalues of a square plus 4a plus 3i will be f of -1 and f of -1 and f of 4, 0 and 35. Thank you, life. Thanks a lot, all of you. Yes, our target 75 is achieved. Now the next target is 95. Let us see. Yes. So what I said, मेरे एहसास को शिद्दत न मिले, मेरे एहसास को शिद्दत न मिले, या मुझे हुक्म कनात न मिले. So just take the screenshot of this. This is very important concept. Very important concept. Take the screenshot of this. This will help you in your exams as well. Next. चलिए. So consider the matrix A. ये एक matrix दिया है इन्होंने 3 cross 3. So for the matrix A, the eigenvalues are suppose lambda 1, lambda 2 and lambda 3, and they have given us the eigenvalues as 1, -1 and 3. 1, -1 and 3. Okay, so what will be the eigenvalues of this matrix A cube minus 3a square? See here. So unless and until, the meaning is unless and until I succeed in my aim, God will not allow me to die. जब तक मैं मेरे लक्ष्य की पूर्ति नहीं करता हूं, जब तक ऊपर वाला मुझे मरने की अनुमति ना दे. That is the meaning of that two lines, those two lines. So let f of a is a cube minus 3a square. So find out f of lambda. क्या करना है आपको? क्या करना है आपको? You have to put a equal to lambda. Okay, sir. So eigenvalues of f of a will be f of 1, f of -1 and f of 3. So f of -1, f of 1, and f of 3. So you can find f of 1. F of 1 will be 1 minus 3, that will be -2. F of -1 will be -1, -3, -4, and f of 3 will be 0. So trace of a cube minus 3a square will be the addition of the eigenvalues -2. Thank you Goluji. -4 plus 0. Answer आया -6. So moving to the next. देखो भाई, I have collected all the points together in 2 slides. All the points related with eigenvalues together in 2-3 slides. See here. So this PDF will be shared to you on YouTube platform. You can use this. These are the very important points. 1, 2, 3. Just go through this. What is invariant vector? A vector capital X which on multiplication by A results in the same vector with some scalar. Then this vector X is called as invariant vector. Invariant vector. Okay. So if you multiply by I on the right hand side in the invariant vector and take this to the left hand side, ax minus lambda I x, and x is common, then you can say that this is nothing but characteristic equation. So यहां से शुरुआत होती है आपकी कॉलेज में. So in this is characteristic equation. So the necessary condition for 2. Okay. So equation 3 is called characteristic equation. This equation is called as characteristic equation. The roots of characteristic equation are called as eigenvalues. Eigenvalues का और भी कई नाम है. They are known by characteristic roots, characteristic values, latent roots और latent values. Eigenvalues हमेशा square matrix के लिए exist करती है. The concept of eigenvalues existing for only square matrix. अगर कोई आपसे कहता है, if somebody asks you to find out the eigenvalues of a rectangular matrix, तो कह देना उससे, चल बाद में आना. It does not exist for rectangular matrix. So the number of eigenvalues existing for a given square matrix is always equal to the order of the matrix. बच्चा ध्यान रखिए, if a matrix is given to you, if somebody asks you how many eigenvalues will be existing for A, so without observing the elements, you can tell how many eigenvalues will be existing here. How many eigenvalues will be existing here? So it depends on the order. अगर आपके पास 2 cross 2 मैट्रिक्स है तो 2 eigenvalues होंगी. 3 cross 3 मैट्रिक्स 3 eigenvalues. For a 4 cross 4 matrix 4 eigenvalues. In this way I can say that the number of eigenvalues existing for a given square matrix is exactly equal to the order of the matrix. Okay? Now eigenvalues कैसी दिखती हैं? अरे वो कैसी होंगी? विचार कीजिए, आंख बंद कीजिए, सोचिए उनके बारे में. Think about him or her. No. Think about them. सोचिए उनके बारे में. Think about eigenvalues. Eigenvalues कैसी दिखती होंगी, कैसी होंगी, उनका हाल पूछिए. So eigenvalues can be real and distinct. Eigenvalues can be real and equal. Eigenvalues can be complex also. Okay. So these are the different natures of eigenvalues. Now all the eigenvalues of a matrix, if you write together, represent together, suppose you have a 3 cross 3 matrix and eigenvalues are 0, 3 and 15. So if you have written all the eigenvalues together 0, 3 and 15, then this representation is called as spectrum of the matrix. अगर किसी मैट्रिक्स की सारी eigenvalues को एक साथ लिख देंगे, if you represent together the eigenvalues of a matrix, then that representation is called as spectrum of the matrix. And what is the largest magnitude available here? The largest magnitude available here is 15. So the magnitude wise largest eigenvalue is called as spectral radius. Magnitude wise largest eigenvalue is called as spectral radius. So spectral radius किसे कहेंगे? मैग्नीट्यूड के हिसाब से सबसे बड़ी आइगन वैल्यू को हम कहेंगे स्पेक्ट्रल रेडियस. रिक्वेस्टिंग ऑल ऑफ यू टू हिट द लाइक बटन. Our target is 95 likes. So sum of eigenvalues is always equal to trace of the matrix. This property is very important and we have utilized this. Product of eigenvalues is always equal to determinant of the matrix. We have also utilized these properties. Now, if you have a singular matrix, then it will have at least one of its eigenvalue as 0. सिंगुलर मैट्रिक्स की कम से कम एक आइगन वैल्यू 0 होगी. मनी spectral radius is the value of the largest possible value of the eigenvalue. So if your eigenvalues are 2, 2, 2, then you can easily say that the spectral radius is 2. विनय कुमार, सिंगुलर मैट्रिक्स मतलब ऐसा मैट्रिक्स जिसका डिटर्मिनेंट 0 होता है. सिंगुलर मैट्रिक्स मींस a matrix whose determinant is 0. For a singular matrix, at least one of the eigenvalue is 0. For a non-singular matrix, none of the eigenvalues are 0. Non-singular matrix की कोई भी eigenvalue 0 नहीं होती है. Okay? लेकिन singular matrix है. If it is a singular matrix, then at least one of the eigenvalue is 0. Sir, if you have a diagonal matrix, or if you have a lower triangular matrix, or if you have a upper triangular matrix, then eigenvalues are exactly equal to the diagonal elements. Eigenvalues are exactly equal to the diagonal elements. Okay, I request all of you to hit the like button. So if you have symmetric matrix and Hermitian matrix, eigenvalues are always Sayyid Tawqir Hashmi. This is very important for GATE. This is very important for GATE. So eigenvalues of a symmetric matrix or Hermitian matrix are always real numbers. So they will be plotted on real axis on complex plane. So complex plane की real axis पर किनकी eigenvalues plot करेंगे? Whose eigenvalues needs to be plotted here on the real axis. So on the real axis you are going to plot the eigenvalues of whom? किसकी? Eigenvalues of real matrix and symmetric matrix and Hermitian matrix. So second point is eigenvalues of skew Hermitian matrix and skew symmetric matrix are always pure imaginary. So they will be plotted on imaginary axis. See this point. Eigenvalues of skew symmetric matrix and skew Hermitian matrix are always pure imaginary. So they will be plotted on. Anudeep, watch my lectures, previous lectures, which is already available on the YouTube and our app also. Everything is there in detail. Okay, beta. And eigenvalues of orthogonal matrix and unitary matrix. The magnitude of eigenvalues of orthogonal matrix and unitary matrix is always 1. So they will be plotted on the unit circle on the complex plane. Next. Okay. If the eigenvalues of a matrix A are lambda 1, lambda 2, lambda 3, what are the eigenvalues of A square? Eigenvalues of A square will be lambda 1 square, lambda 2 square, lambda 3 square. Eigenvalues of A cube क्या हो जाएंगी? Lambda 1 cube, lambda 2 cube. Thank you, Jones Victor. Eigenvalues of A inverse will be 1 by lambda 1, 1 by lambda 2 and 1 by lambda 3. Eigenvalues of adjoint of A will be determinant A upon lambda 1, determinant A upon lambda 2 and determinant A upon lambda 3. Very good evening to all of you. We are just falling 6 short of a century. Just wait. Adjoint of A, eigenvalues of adjoint of A are determinant A upon lambda 1, determinant A upon lambda 2 and determinant A upon lambda 3. All of you please hit the like button. Yes sir. Then eigenvalues of A transpose. Eigenvalues of A transpose and eigenvalues of A are always same. Eigenvalues of any function of A. Eigenvalues of any values of A will be f of lambda 1, f of lambda 2, f of lambda 3. So, जिसके मिलने से खुदा बन जाऊं, जिसके मिलने से खुदा बन जाऊं, ए खुदा मुझको वो दौलत ना मिले. जिसके मिलने से खुदा बन जाऊं, ए खुदा मुझको वो दौलत ना मिले. इतना भी मसरूफ तू न कर, इतना भी मसरूफ तू न कर मुझे कि तुझसे मिलने की फुर्सत न मिले. क्या बात है. So these are some points regarding to the eigenvalues of matrix A. We will solve some more questions and then we'll again discuss some more content. So, see here, eigenvalues of a matrix are given as 1, 2, 4. Okay. So, what are the eigenvalues of A inverse? reciprocal of these. Eigenvalues of A inverse will be reciprocal of these. Okay, then yes, we crossed the 100 mark today. So today also, yesterday also we crossed the 100 mark. Thanks a lot to all of you. So let us put a new target and 5 dislikes. Shabash. 5 dislikes. See, people. Superb. So let's move ahead. A inverse transpose. A inverse transpose. So eigenvalues of a matrix and its transpose are same. So 1, 1 by 2, 1 by 4. So these are the eigenvalues. These are the eigenvalues. These are the eigenvalues of this matrix. Okay. So what we need? Determinant. So determinant of A inverse transpose will be the product of the eigenvalues. 1 into 1 by 2 into 1 by 4. That will be 1 by 8. Chaliye. Gate 16 का सवाल है. Yes. Moving to the next. Moving to the next. Yes, sir. Come on. Next. Eigenvalues of a matrix. Eigenvalues we can classify into 2 categories. Distinct or repeated. Okay, sir. So if eigenvalues are distinct, one case, eigenvalues are repeated, then another case. So if eigenvalues are distinct, then how many independent eigenvectors will exist? So I have got 6 dislikes. So requesting all of you to increase our like proportion. Students who really wants this session, really enjoying this session, they just increase this like proportion against this dislike proportion. I don't know why people are disliking it. Anyways, it's their choice, their discretion. They are not students. They are frustrated teachers. Sometimes came to watch my lecture. So in their lecture, they do follow my notes. But when it comes to actually appreciating one's effort, they just fail in doing that. Okay, so they cannot appreciate the person whom they follow. So we cannot do anything for them. Let's pray. May God bless them all. Okay. So moving to the next. So if eigenvalues of a matrix are distinct, then how many independent eigenvectors will exist? The number of independent eigenvectors will be always equal to number of eigenvalues. But when eigenvalues are repeated, then number of independent eigenvectors is given by the concept of geometric multiplicity and algebraic multiplicity. Okay, so I request all of you to watch my session on these eigenvalues and eigenvectors also, so that you will be able to get this concept in the right place. Okay, so see here, when eigenvalues are distinct, number of independent eigenvectors is equal to number of eigenvalues. Okay, great. When number of independent eigenvectors equal to number of eigenvalues, then matrix can be diagonalized. So what is the meaning of matrix can be diagonalized? That you can have a diagonal matrix of this pattern, D equal to B inverse AB. Okay, so if eigenvalues are distinct, number of independent eigenvectors is equal to number of eigenvalues, so matrix can be diagonalized. Regarding the content part, you can watch my previous lectures, beta. Yes? Yes, sir. See here. Find the eigenvalues of the matrix A 3403 and hence determine whether it can be diagonalized or not. So here you have to tell whether you can whether this can be diagonalized or not. Okay? Yes, sir. So you can see here, this is an upper triangular matrix, so eigenvalues are same, 3. Lambda 1 and lambda 2 both are same. So how many times these eigenvalues repeated? 2 times. So the eigenvalues is repeated 2 times. So algebraic multiplicity is defined as a term denoting the number of times eigenvalue is repeated. So eigenvalue is repeated 2 times. Algebraic multiplicity is 2. Now, how many independent eigenvectors will be existing for this eigenvalue? That is given by a concept called as geometric multiplicity. What is geometric multiplicity? Geometric multiplicity will be Q equal to n minus rank of A minus lambda I. So this is the concept of geometric multiplicity. So Q equal to n. What is the order of this matrix? 2. Rank of this matrix A minus lambda I. Lambda I is 3. So A minus 3i. So 3 minus 3 will be 0 and 4 and 0 remains as it is. So what is the rank of this matrix? इस मैट्रिक्स का रैंक कितना है? 1. So I have got geometric multiplicity equal to 1. Geometric multiplicity tells you how many independent eigenvectors will be existing for this eigenvalue. So for this eigenvalue 3, how many eigenvectors? Only 1. If somebody asks you how many eigenvalues, so eigenvalues are exactly equal to the order. So number of eigenvalues equal to 2 and number of eigenvectors equal to 1. So you can say that number of eigenvalues is not equal to number of eigenvectors. Matrix A cannot be diagonalized. What is the condition for matrix diagonalization? What is the condition for matrix diagonalization? The condition for matrix diagonalization is the number of eigenvalues. The number of eigenvalues should be equal to number of eigenvectors. So in this matrix, number of eigenvalues and number of eigenvectors are not equal. So we can say that matrix cannot be diagonalized. आगे चलते हैं. चलिए, move to the next. The number of linearly independent eigenvectors of this matrix. चलिए find कीजिए. So eigenvalues are 3, 2, 2. For this eigenvalue 3, one eigenvector will be always existing because this is distinct. And for this repeated eigenvalue, how many eigenvectors will exist? Yes. Algebraic multiplicity will be 2. Geometric multiplicity we have to find out. So Q equal to n minus rank of A minus lambda I. So lambda I is this repeated eigenvalue. N, order of the matrix, rank of A minus 3i, sorry, A minus 2i. Zero, 3 minus 2 is 1. So what is the rank of this matrix? Rank of this matrix is 2. So Q will be 1. Q will be 1. So for this eigenvalue 3, one eigenvector x1. For this repeated eigenvalues, Q equal to 1. It means only one eigenvector, that is x2. So total eigenvectors are 2. Okay. Total number of independent eigenvectors are 2. Okay. Yes sir. Now my question is, can it be diagonalized? क्या ये matrix diagonalized हो सकता है? Can this matrix be diagonalized? No sir, this matrix cannot be diagonalized. This matrix cannot be diagonalized as the number of eigenvalues is not equal to number of eigenvectors. Okay? Yes sir. Next. The number of linearly independent eigenvectors for this matrix. चलिए जवाब दीजिए. n is the order, rank A minus lambda I. Lambda I is 1. Repeated eigenvalue. Repeated eigenvalue. So A minus I. So diagonal elements में से 1 minus कर दीजिए. Remaining elements as it is. So Q will be how many independent eigenvectors? How many independent eigenvectors? Q will be rank is 1. Q will be 2. So number of independent eigenvectors will be 2. Let us move to the next. Eigenvalues are 1, 1, 1. Number of eigenvectors are 2. Okay, correct yourself, all of you. Yes. Requesting all of you to hit the like button. We'll move to the next. Yes, sir. Golupal. N minus rank of A minus lambda I. N is 3. Rank of A minus lambda I. Lambda I is the repeated eigenvalue 1. So A minus I. So from this you have to form A minus I. A minus I means from the matrix A, diagonal element should be subtracted by, from the diagonal element you have to subtract 1. Yes. So subtract 1 from the diagonal elements. So 0, 0, 0 on the diagonal. Remaining elements as it is. So how many non-zero rows are there in A minus I? Only 1. So rank will be 1. 3 minus 1 will be 2. आगे चलें. Shall I move to the next? Yes, sir. Next. Somajit will plan something and will let you know. The next Sanket Patil, you don't know the concept, beta. So if you want to learn the concept, watch my previous lectures on YouTube. I have completed this eigenvalues and eigenvectors in much detail. I have taken 10 to 12 hours lectures earlier. Please go and watch those lectures also. Next. चलिए. In matrix equation Ax equal to R, one of the eigenvalues of the matrix A is, okay, this A, x equal to R. So actually Ax equal to lambda x. So R is given. R is given as 32, 16 and 64. So if you take 4 common, if you take 16 common, you will be getting 2, 1, 4. So 16x, lambda x equal to 16x. So you can easily say that lambda equal to 16. See here, they have given that Ax equal to R. Okay, sir. So we know that Ax equal to lambda x. So lambda x becomes R. So from this R I have taken 16 common. Yes. So moving to the next question. Is that fine? Understood everybody? Chaliye. Let M be a 4 cross 4 matrix. Consider the following statement. M has 4 linearly independent eigenvectors. M has 4 distinct eigenvalues. Okay. Yes, sir. See here. This S2. See this S2. If a matrix has 4 distinct eigenvalues, then it will be having 4 independent eigenvectors. So we can say that S2 implies S1. This is the property beta. Nilesh Gulani, Ax equal to lambda x. This is the eigenvector equation. I started the session with this equation. Ax equal to lambda x. Okay. So x is the invariant vector representing the eigenvector and lambda is the eigenvalue. So if A is the given matrix, x represents the invariant vector and lambda is the eigenvalue. You can use this equation to solve such questions. Chaliye. Consider the matrix A whose eigenvalues are corresponding to the eigenvalues lambda 1, lambda 2 are given. The values of x1 transpose into x2. So x1 transpose, this is x1, its transpose will be 70, lambda 1 minus 50. x2, lambda 2 minus 80, lambda 2 minus 80 upon, not upon, second element is 70. So multiply this. So 70 times lambda 2 minus 80 and 70 times lambda 1 minus 8. 70 times lambda 1 minus 50 plus 70 times lambda 1 minus 50. So 70 common, lambda 1 plus lambda 2. Lambda 1 plus lambda 2 minus 80 minus 50 is minus 130. Now lambda 1 plus lambda 2 is nothing but trace of A. Trace of A is the diagonal elements addition. 50 plus 80 is 130. So why we are getting 0 as the answer. 0. Shahid ho gaya hai to. Next, requesting all of you to hit the like button. Hit the like button. Next question. See here. The matrix A, this is the matrix A, has 3 distinct eigenvalues and one of its eigenvector is 101. Which one of the following can be another eigenvector? Remember that the given matrix is following this property. The given matrix is following this property. A transpose is equal to A. If you take the transpose of this matrix, that is interchange row into column, you will be getting the same matrix. So this matrix is symmetric matrix. So this matrix is symmetric matrix. Okay. Now for a symmetric matrix, eigenvectors are mutually orthogonal. Eigenvectors are mutually orthogonal. So they have given you one eigenvector 101. So just you have to find out the another one, so that the other one when multiplied with this will give you 0. That is mutual orthogonality. So I can say that C is the option. So according to option C, if I take 1 0 minus 1 and multiply this 1 0 minus 1, then what will I get? 1 plus 0 minus 1 will be 0. So option C is the correct answer. Yes, shabash. Requesting all of you to hit the like button. Ensure that you would have hit the like button, shared the link among your friends so that many other students should take the advantage of this. So this is very important property of symmetric matrix. You can make use of it. Next, suppose that the eigenvalues, okay, this question already we solved. We move to the next. For the matrix A, 5, 3, 1, 3, one of the normalized eigenvector is given as. So, see here, what you have to do? You have to find out the eigenvalues. Okay, find eigenvectors. Okay, now if your eigenvector is AB, then normalized eigenvector is, if your eigenvector is like this AB, then normalized eigenvector will be A upon root A square plus B square and B upon root A square plus B square. So you just use this property, find out the eigenvalues and eigenvectors of this matrix, find out the eigenvalues and eigenvectors of this matrix, and then calculate the normalized eigenvector by using this format. Okay? Yes, sir. See here, a vector is given as 4 minus 2 minus 6. So what will be its norm? Norm will be under root of 4 square minus 2 square and minus 6 square. So you can add and find out, you will get root 56. So if you divide by this norm, in this you will be getting normalized eigenvector. So normalized eigenvector is denoted by x cap. It is minus 4 upon root 56, minus 2 upon root 56, and yes, the another one is minus 6 upon root 56. Okay, next. See here. When eigenvector is given and you want eigenvalue, you can use this equation Ax equal to lambda x. One minus 1 0, minus 1 2 minus 1 0 minus 1 1. What about x? 1 0 minus 1. Multiply them. Row into column. 1 into 1 0 0 minus 1 plus 1 will be 0, and then 0, row into column, 0 and minus 1. So what is this? This should be lambda into x. So what is lambda? So lambda equals to 1. So requesting you to hit the like button and do follow me on GradeUp app also, so that you will be getting some updates regarding my further lectures on this YouTube platform or our app. Take the screenshot of this. Next. Next. Okay. You know Cayley-Hamilton theorem. Every square matrix satisfies its own characteristic equation. हर एक स्क्वायर मैट्रिक्स अपने ही कैरेक्टरिस्टिक इक्वेशन को सेटिस्फाई करता है. हर एक स्क्वायर मैट्रिक्स अपने ही कैरेक्टरिस्टिक इक्वेशन को सेटिस्फाई करता है. एवरी स्क्वायर मैट्रिक्स सेटिस्फाइज इट्स ओन कैरेक्टरिस्टिक इक्वेशन. The characteristic equation of a 3x3 matrix is given. Okay. If I denotes the identity matrix, then inverse of P will be. Okay. So equation is given as lambda cube plus lambda square plus 2 lambda plus I equal to 0. This is the equation given to you. Okay. So by Cayley-Hamilton theorem, you can replace lambda by A. According to Cayley-Hamilton theorem, you can replace lambda by A. One can be replaced by I. Multiplying by A inverse both sides. So A inverse will be minus A square minus plus A plus 2I. Minus is taken common. So matrix given is P. Matrix given is P. So my answer will be in terms of P. Minus P square plus P plus 2I. Just write everything in terms of P. Simple question. Next. Requesting all of you to hit the like button so that this will be a motivation for me. I will be coming to their class daily. Next. If A equal to this matrix, find out A raised to 4. So we will be solving this using Cayley-Hamilton theorem. So find out the characteristic equation. So characteristic equation means you have to subtract lambda from the diagonal values. Sir, this will be the characteristic equation if you equate it to 0. Okay. So this is an upper triangular matrix. Its determinant will be product of the principal diagonal elements. Just simplify this. Lambda plus 1, lambda minus 1. Lambda square minus 1. Lambda plus I, lambda minus I. Lambda square plus 1. A minus B, A plus B. A square minus B square. So according to Cayley-Hamilton theorem, you can replace lambda by A. So A raised to 4 is nothing but I. ये हो गया हमारा आंसर. टेंटन. चलिए मार्क कीजिए. इतना भी कर्म उनका कुछ कम तो नहीं है. इतना भी कर्म उनका कुछ कम तो नहीं है. गम देके वो पूछे हैं कोई गम तो नहीं है. चलिए फॉलो इट. नेक्स्ट. कम ऑन फास्ट. You should ensure that you would have hit the like button. Shabash. Next. Given that A equal to this matrix and I is the unit matrix, find out the value of A cube. Okay, sir. So, find out the characteristic equation. Minus 5 minus lambda minus 3. Thank you, Samantha. So lambda square plus 5 lambda plus 6 equal to 0. So in this characteristic equation, you can put A equal lambda equal to A. Shabash, shabash, Ayush Bisain. So a cube will be a into a square. My only request to all of you, शाहीन भाई मुझे इंफॉर्मेशन नहीं है चंदन झा सर का, चेक करना होगा आपको शेड्यूल में. यू नीड टू चेक इन द शेड्यूल. कल आप चंदन झा सर का कल बर्थडे था, आपने विश किया क्या? -5a square -6a. So a cube will be -5a square. A square is -5a minus 6i minus 6a. So we can easily say that it is 19a plus 30i. So this is one technique by which we can, this is Cayley-Hamilton theorem, one application. But in my regular lectures on Cayley-Hamilton theorem on YouTube, on app, and in paid classes, I have taken so many varieties, so many questions, and so many approaches regarding this Cayley-Hamilton theorem. Here I am just using the conventional approach. That's it. So that's all for today's class. Thanks a lot, and really it was very nice to have you all in this session, and I request all of you to share this link to your friends as well. Those who have not attended this, hit the like button, share the link to your friends, subscribe our channel, and do take care of yourself and your parents. We'll meet sometime later. Thanks a lot. So I hope you should get some good marks. These sessions will be helping you in upcoming exam, and my best wishes are always with you. May God bless you, and may God bless to all of you. Thanks a lot. चलिए, bye-bye. Thank you. Do hit the like button if you have not done so. Thank you Kakali Sharma, Kakali Samantha. Thank you Hemanti Patel, Golu, Dhruv, Ayush, Satya, Priya, Vikas, everybody. Thank you beta.